Can you see my pointer?
I think we cannot see your mouse pointer. Yeah, I can see now.
Okay, thank you. Yeah. Okay, I'll start my presentation. Hi everyone, I'm Minjeong from KAIST, and today I'm excited to introduce our paper, Completing Missing Annotation, Multi-Agent Debate for Accurate and Scalable Relevance Assessment for IR Benchmark. This paper is now under review at iClear 2026, and we are the co-author of this paper. So let's begin with a quick overview. I'm sure most of you have seen this figure many times. The retrieval augmented generation combines retrieved knowledge from external sources with the parametric knowledge of large language models. And it improves the response accuracy and also reduces the hallucination. And how it works is that the retriever first finds the relevant documents for a given query from an index corpus. And then these documents are passed to the frozen LLM to generate the final answer. So how we evaluate the RAG system is that traditionally the two core of the components of RAG, which is retriever and generation, are commonly evaluated separately. So the retriever evaluation focuses on whether the retriever successfully finds the relevant documents compared to the gold relevance labels in IR datasets. And these gold labels in IR datasets are acquired by the relevance assessment, where they assess the relevance between query and the document that are in the indexed corpus. While the generation evaluation focus on whether the LLM produced the correct answer compared to the gold answer in QA datasets. And most of RG systems are evaluated only on this generation performance. However, evaluating only one component obscures the actual failure point of the overall RG pipeline. So we can now know the failure of RG pipeline is according to the retriever failure or generation error. Yeah, so in our paper, our task is in this relevance assessment. Is my connection is unstable or
Yeah, it seems like there is a lagging in network.
uh,
But yeah, it is not that serious. So yeah.
think, okay, then I'll continue. Um, so this is our motivations. The currently information retrieval datasets has some limitation. As I mentioned before, the ground truth label in our datasets are obtained through relevance assessment. But the human annotator usually assess only a small subset of the corpus. So, however, since evaluating the entire corpus is infeasible, so many potentially relevant documents remain unjudged, and we call this the holes. And these holes, because of these holes, even though the retriever retrieves relevant documents, it is mistakenly regarded as failure. So this leads to the underestimated retriever scores and unreliable evaluation. And it's also distorts our understanding of retriever and generation interplay. For example, because of the host, the performance of retriever and the generation performance are not matched. So in this figure, the green line is the retriever performance, which is sorted, and the yellow line is the generation performance of the RAG system. And we can see there a huge gap between the two lines and they're not aligned. And more specifically, when you see the BM25 Q2 dock, it has the higher generation performance than SBERT, but its retriever performance shows lower. So it demonstrates that some retrieval performance seems to be underestimated compared to the generation. So to solve this problem, some paper tried to assess a large portion of the corpus. So they utilized large language model to cost effectively automate the data annotation pipeline. So they replace expensive human annotators so it can assess a large portion of the corpus. And also the paper DIRAS demonstrate that fine-tuned small LLM achieves performance on par with larger models. However, they use a single agent which suffer from overconfidence and bias because they serve as the sole judge. And also they has a lack of nuanced contextual understanding compared to the human annotators. So there was the other approach to use human with AI and human hybrid relevance assessment. They try to mitigate failures of LLMs by escalating uncertain cases to human annotators. So they use confidence score-based escalation method where they escalate the cases when the confidence score is low. So they calibrate LLM confidence score into relevance probability. They train the calibration model by logistic regression with human label data sets. However, they still annotate label by a single agent, which is still suffering from low accuracy and overconfidence. And also, this framework requires sufficient human data and training step to calibrate the model. And often, miscalibrated confidence score often fail to escalate genuinely ambiguous cases. So here is our proposed method. I will briefly explain about our pipeline. So we utilize multi-agent debate for relevant assessment. So first, to mitigate the overconfidence and bias of single agent, we compel each agent to have an opposing initial stance. So the one agent should argue relevance and the other should argue irrelevant. And then we compel two debates for multiple rounds. And finally, when they reach the consensus, we just label that relevance by automated annotation. But when the disagreement persists for multiple debate rounds, we escalate the cases to human annotation. And during the human annotation, we provide the debate history of LLMs to support human annotators. And these are the key points of our framework. First, we utilize multi-agent debate, which provide opposing initial stance and multi-round reciprocal critique. This mitigates single perspective bias and provides more accurate label with less human effort. And second, we use agreement-based escalation rather than confidence score. This is a stronger signal of correctness than a single model confidence because the disagreement naturally pinpoints the uncertain cases that require human. And finally, we utilize debate history to support human annotators with organized argument, not from scratch. So the annotators can know which point was for disagreement. And now I will explain more details about our method. So the task was the answer-aware relevance assessment. So we have to decide whether a candidate chunk contains sufficient information to answer a gold answer with a given query queue. So the chunk have to contain the gold answer, not just general answer. And then we label the chunk as relevant or irrelevant with binary classes. And how our multi-agent debate work is that first we initialize LLM agents with opposing stances to enforce an explicit divergence of perspective. And then we compel agents to confront and critique opposing views. In this step, it is able to revise their labeling decision. So we input the query candidate chunk, ground truth answer, and debate history from previous round. And then each agent output the critique of opponent's arguments, relevance label, and supporting reason. Then finally, if disagreement persists after max rounds are, cases is considered uncertain and escalated to human annotators with debate history. But if agents reach agreement, the final debate label is just assigned automatically. Let's move on to experiment. To evaluate the accuracy of our pipeline, we sample 700 query chunk answer triplet from the RAG dataset, which cover diverse domains such as MS Marco, NQ, and Lotte. And then we collect ground truth relevance labels by expert human annotators. We use balanced accuracy because there are some imbalance in classes between relevance and irrelevance. And for baseline, we compared three baseline. The first one is LLM-GIST, which use a single agent method without any escalation. And second is LARA, which is a confidence-based escalation method. And we also compare with the non-expert annotators recruit via Amazon Mechanical Turk. Here is the result of our pipeline. The orange dot, which is our pipeline, shows the highest balance accuracy with low escalation ratio. The escalation ratio means that how many chunks did you escalate to human annotators, which also means annotation cost. So DREAM surpassed non-expert annotators while requiring escalation only 3.5 cases. And not surprisingly, LLM just suffered from low recall on irrelevant cases because the absence of uncertainty-based escalation. But it shows the high recall on relevance cases, which demonstrate a single agent tends to overestimate the relevance. And the LARA, which is the confidence-based escalation method, outperforms LLM-GIST. This demonstrates the effectiveness of the confidence-based strategy. However, it requires escalating nearly 50 of the cases to reach performance comparable to the DREAM. But the DREAM, which is our framework, only escalates 3.5 cases. And also we did evaluation study about debate round and adjudication strategy. We use LLM and human to adjudicate the escalated cases. All other cases are labeled automatically by DREAM. And also we compile the debates until 3 rounds, but more debate round with LLM adjudicator bring no further improvement. So we just set 2 rounds as the default. And not surprisingly, human resolve uncertain cases more accurately than LLM adjudicator So it supports our AI to human escalation to maximize annotation quality. Also, we investigate the consensus stability across the debate rounds 2 to 5. And as a result, 96% of consensus cases are maintained up to 5 rounds debate. This means that the agreements arise from substantive reasoning rather than random chance. And also, we compare the human annotation quality with and without debate history. Providing debate history raises IAA, which improve consistency and labeling accuracy. So this research is the unique advantage of DREAM over the just confidence-based method, which demonstrates genuine AI human strategy. Next, we applicate in the real-world cases to IR benchmark. To investigate our framework effectiveness, we assess the relevance on the real IR benchmark datasets. So our large-scale and low-cost labeling uncovers substantial missing relevance labels, more than 480% of the exist gold chunks. So for target benchmark, we collect the diverse domains and corpus sizes. And to ensure a large and various candidate chunk pool, we concat the top 10 retrieve results from the various retriever system, such as sparse, dense, re-ranking, and query rewriting. So finally, when we assess the relevance with stream, only 3.5 cases just need the human annotators, and the other cases can automatically labeled by our automated DREAM framework. So this is the result of relevance assessment on existing benchmark. Here, the hole ratios refer to the fraction of detected holes within the top K chunks retrieved by each system. So this percent is how many relevant chunks newly identified in each retriever top 10 chunks. The advanced fusion method, such as re-rank or rewrite, and recent systems show higher hole ratio than conventional ones. It is because when they construct the IR benchmark, they use the conventional retrievers to construct the candidate pool, and then they just annotate only small subsets of that corpus. So current benchmark or underestimate advanced retrievers due to the pervasive unlabeled relevant chunks. So benchmark refinement is essential to ensure fair and reliable evaluation. And we re-benchmarked the retriever system after hole filling. Here is the retriever performance on our refined benchmark, and the subscript numbers indicate the improvements over the original benchmark through hole filling. So all systems show higher hit rate after hole filling, but improvements varies across system. Especially rewriting shows the largest gain in hit rate, which is consistent with its high hole ratio. So system with many missing relevant chunks are penalized when holes remain. Also, we compute some alignment metric of retriever and generation. So here, the alignment means whether improvements in retrieval accuracy effectively carry over to downstream generation performance. So we said the retriever and generation performance are aligned when their performance are same, 0, 0 or 1, 1. And the other cases, we regard it as misaligned cases. And so we compute it as a reg align metric. The after whole filling with stream, it substantially improved the alignment in RAG system, 70% to 84%. So it demonstrates that whole filling R data sets show the reliable analysis of RAG interplay. Finally, we also compute the normalized retriever and generation performance before and after refining the data set. Here in the figure, we can see the after whole filling on our bridge benchmark. The two lines becomes more aligned and the gap between two lines decreases. And we can see that many of the retriever system rank or shifts. This means the original benchmark distorts the retriever comparison. So DREAM offers a stronger basis for RAG evaluation. Here is the key takeaways. Inaccurate evaluation of retriever and generation obscures the root causes of RAG system failure. So a reliable and faithful evaluation framework is essential. And since labeling every document in a large corpus is infeasible, existing IR datasets inevitably underestimate retrievers due to incomplete relevance annotations. So it is preferable to assess relevance dynamically rather than relying solely on static ground truth document labels. Yeah, this is end of the presentation. So if you have any question, feel free to ask.
Yeah, thank you for your presentation, Minjeong. So, if there are any questions to Minjeong, feel free to ask her.
I want to ask whether you did human performance evaluation by hiring some annotator.
Do you mean for non-expert annotators or?
I heard that you mentioned uncertain cases will be evaluated by human judges.
Yeah. The uncertain case is not evaluated human judges. They just human label that cases for final labels.
So does that mean the system needs human in the loop?
Yeah, so our approach is AI and human hybrid approach. So we
Okay.
need human annotators.
Okay, thank you.
Thank you.
I have a quick question regarding this rebate procedure. So after the rebate, could you please clarify whether there's a judge large language model will summarize the debate results for annotation, or how this conclude the debate towards the annotation?
Sorry, can you explain one more about your questions?
Yes. This is about after the debate, right? After debate, you will get probably a multi-round conversation records, and how this system summarize such conversation towards the labeling. Do you use, for example, for the results part, is it done by another judge language model, or you maybe one of the debate agent conclude that?
Yeah. So do you mean about the adjudicator for after debate round?
Yeah, after debate. Yeah.
Actually, we use the same LLM model for debate agents and also for adjudicator. But
I see you use the same model for that.
yeah,
I'm just curious, like, how accurate this adjudicator language model can summarize the multi-round debates information into the correct label. But based on the results you show here, especially if we look at round equals to 2, the performance is quite close to a human summarizer, right?
yeah, it is close to human summarizer, but in
Mhm.
this case, we escalate only 3.5%. So when we compute the accuracy on three only on 3.5 cases, maybe the performance gap will be increased between LLM adjudicator and human.
Got you. One more question regarding this adjudicator large language model. Its context is just the debate uh, dialogues, so it cannot see any further information. You don't, right? So you don't provide any additional context for this adjudicator for labeling.
Oh no, actually we provide the necessary components, which is query, chunk, and gold answer, and then provide the debate history of the large language
Ah,
model. So yeah, this adjudicator can know about the just contextual flow.
okay, interesting. So then how this can isolate this adjudicator not making its own judgment based on the chunks and the questions? How do we ensure like it's indeed focused on or really analyze the debates information to make such a labeling rather than based on the other components?
So in our work, we just actually use just fine-grained prompting for adjudicator. So um, we use different prompts to debate agents and adjudicator, and we enforce the adjudicator to just read whole of the debate history and then label the relevance of the chunk.
Okay, I
Yeah.
see. Yeah, I'm asking because I have another intern working on some debate like um, multi-agent system.
Hmm.
So if we introduce another judge, another independent language model as a judge, so
Hmm.
how to define this independence could be really tricky, right?
Yeah. Actually, if you interested in some diverse LLM model, we have had some experiments, not on the adjudicator, but for just debate agents.
Mhm.
Uh, Wait, let me share. Yeah, because of time limit, I just skipped this content, but we increased the agents number of debates 2 to 4, and also use heterogeneous large language model. And we also adjust the temperature values, but um, yeah, I will explain. So when we use the more agents 2 to 4, it is like hard to reach the consensus. So it's the escalation ratio are increased, but actually the accuracy are slightly decreased for in this case. So
Mhm.
there's no effect of increasing agents numbers. and also for just heterogeneous large language model. For default, we use the Llama family models, but we add some QN models for relevance assessment. We combined Llama and QN and to investigate some order dependency between the prompts. We also had an experiment of QN first and then Llama for later. But the research showed that using heterogeneous model reduced the model specific bias, because when you see only using two Llama, it shows the high recall on relevant cases, but for QN, it shows the high recall on irrelevant case, which show the Llama overestimate the relevance and the QN underestimate the relevance of Korean chunk. But when we use the combined of two models, some this kind of bias can mitigate it by using the two heterogeneous model. But when we see the overall accuracy, the QN shows very low accuracy compared to Llama. So when we use the two models, the overall performance just decreases compared to Llama. So we have to consider the performance of the large language models. But I think using the heterogeneous LLM can mitigate the bias of just single model family.
That's fair. Yeah. I think that you discussed the bias introduced by that's important and very helpful.
Yeah.
I don't have further questions, so I've passed the opportunities to the other audience. Thank you.
For question.
Yeah, thank you for your insightful question, Xiaoxiaori and Sandong. And is there any other questions from other students? Yeah, it seems like there's no more questions. So yeah, let's wrap up today's seminar at this point. And let me introduce the next week's presenter. So yeah, next week, Woo-Chang from GIST will present the paper titled Prismatic Synthesis, Gradient-Based Data Diversification, Boost Generalization in LLM Reasoning. So yeah, Happy New Year, everyone, again, and let's meet at next week. Thank you for attending today's seminar.